Okay, so question number 2. Is phosphorus trichloride polar or nonpolar? Follow the steps below to determine if the molecule is polar or nonpolar. So first, let's sketch out its Lewis structure so that we can visualize what this molecule may look like. So when writing out the Lewis structure, we first need to find out the total number of valence electrons for this compound. So phosphorus has 5 valence electrons, and chlorine has 7. And since there are 3 chlorine atoms, we multiply this by 3, which gives us a total of 26 valence electrons. So now let's try to draw out the skeletal structure. We'll have phosphorus as our central atom, and then 3 single bonds to the chlorines. And I can also draw in all of the lone pairs on each chlorine atom as well, like so. And if we recall that each bond contains 2 bonding electrons, and we have 3 bonds, plus each chlorine atom has 6 non-bonding electrons. If we count out all the electrons I've drawn so far, I only have 24 out of the 26. So for the remaining 2, I'll put as a lone pair on the phosphorus. So now we have our final Lewis structure for phosphorus trichloride. So now we can follow the steps that they give us in the question. So step 1, the phosphorus chlorine bonds are blank. So I think they mean to ask, are they polar or nonpolar? So to find out the polarity of these bonds, we need to look at the electronegativity difference between phosphorus and chlorine. So let me look up electronegativity values for these elements. So we'll use this one here. Chlorine has an electronegativity value of 3, and phosphorus is 2.1. So the electronegativity difference between the two is 0.9. So therefore, the phosphorus-chlorine bond is polar, and we know that because its electronegativity difference is greater than 0.4, but it's less than 1.69. So that answers step A. Step 2 wants us to look at the molecular geometry of this molecule. So by looking at our phosphorus atom, we can see that it contains 1 lone pair and 3 bonded atoms. So if we look at a VSEPR chart, we can find out its molecular shape and electron geometry. So when we have 1 lone pair and 3 bonded atoms, we have a trigonal pyramid molecular shape. Trigonal pyramid molecular shape. And a tetrahedral electron geometry. So now I know the electronegativity difference between phosphorus and chlorine, and I also know the molecular shape. So if I were to draw dipole moments going towards the chlorine atoms like this, notice that they don't cancel each other out because of the lone pair on the phosphorus. So we have a net dipole moment, kind of like this. And we can have we can say that we have a non-zero net dipole moment. And because of this, our molecule is polar. And this is due to the polar bonds plus its molecular shape. Okay, so the junior tutor said that to determine the polarity of a molecule, we need to first write its correct Lewis structure and molecular geometry. So they kind of summed up how we would do that. They got 26 valence electrons and drew the correct Lewis structure. And they didn't show the calculation of the electronegativity difference, but they already knew that it would be polar. They found that the Vesper shape looks more like this, and it's trigonal pyramid. So the molecule is polar because the bond dipole is occupied only in one direction, from the phosphorus atom to the lone pair, and lone pair to the chlorine atoms. Yep. So this solution is correct.